All right, guys, we're going to take a look at pressure conversions. I know we've done some of these, and many of you have already taken our formative on that, but I wanted to give a video review out there just in case some of you might still be struggling with how to convert just with inside of our own different pressure units. The standard pressure unit is going to be atmospheres, and one atmosphere could be equal to 760 millimeters of mercury. It could also be equal to 101.3 kilopascals. It can also be equal to 14.7 psi. And we also have 760 torr, T-O-R-R, as another measurement that we can have from there. So one atmosphere can kind of be equal to all of those different ones. And with the pressure conversions, really what we want to do is be able to take it from one unit and make it into a different unit if we're trying to solve later on down the road some of our gas laws. We need to make sure that we have them sometimes in standard temperature and pressure, which would be into atmospheres. Sometimes we just need to make sure that we're all in one same unit as we kind of move through. So if I had 2.5 atmospheres and I really wanted to know how many psi's those are, really in order to do that we just need to set up a conversion factor to be able to get that done. And so what we do is we take what we are given, our 2.5 atmospheres, we're going to put that over 1, and we're going to multiply it by the conversion factor between the two known quantities. ATM, atmospheres, which is what we already have, and PSI, which is what we're always looking for. So since one atmosphere is equal to 14.7 PSI, we always put what we have or what we are given on the bottom. So our one atmosphere is going to go on the bottom here. We always put what we're trying to convert into on top, and since one atmosphere is equal to 14.7 psi, that is going to be our conversion factor. And so from there, we're just going to multiply our fractions here, 2.5 times 14.7. And that gives us 36.75. And that is going to be in PSI because we canceled out our atmosphere, and that's going to be over 1. Again, the atmospheres cancel out. So really, we would take that to 36.8 PSI for our solution there. Again, it's just making sure that we know how to move from one unit to the next unit. Again, canceling out units, leaving the appropriate unit available for us, PSI, etc. from there. We can also take a look at what do we want to do to get to multiple other areas. So let's say if I had 158.3 kilopascals and I wanted to know how many millimeters of mercury that is. I can still solve this problem. You can do it a couple of ways, the way to set up your conversion factor. I always like to take everything into atmospheres just so that I know I've done it correctly, and then from atmospheres into the next unit that we're trying to get to. So I like to start out with taking what we've been given, 158.3 kilopascals. We'll put that over 1. I like to take it into atmospheres first just to get it all kind of uniformed as we go through. Again, we put the unit that we know on the bottom so that we can cancel out 101.3 kPAs. We put what we're always trying to get into on the top so that our units can cancel out. And so we simply take our 158.3 and we're going to divide that by 101.3, and that will give us a total of 1.56 atmospheres. So from there, now that I'm in atmosphere, I can set up my next little run of equations. I wanted to get into millimeters of mercury. So in order to get into millimeters of mercury, I need to know that 760 millimeters of mercury equals 1 atmosphere. So I again put what I know down on the bottom because I want to be able to cancel those out. What I'm trying to get converted into, millimeters of mercury on top. And so for this one, I'm going to take my 1.56, I'm going to multiply it by 760 millimeters of mercury, and I come up with 1,185.6 millimeters of mercury. So 158.3 kilopascals is equal to 1,185.6 millimeters of mercury. Again, just showing you a different couple of ways to convert those units from, again, looking at the idea that 1 atmosphere is equal to all of these different styles or different pressures that we can measure.